Good morning, students. In this video, I am going to display the question from the Neet from previous year question from P blog. Let us see the first question. Before going to the question, please, if you are so far you didn't subscribe my video channel, means please subscribe my channel. Okay, Vetri and Vetri. Let us coming to the topic. P block, the first question. It is because of the inability of the electron of the ns2 electrons of the valence shell to participate in the bonding that first one Sn plus 2 is oxidizing while Pb4 plus is reducing. B option Sn plus 2 and Pb plus 2 are both oxidizing and reducing. C option Sn plus 4 is reducing while Pb4 plus is oxidizing. The next option D Sn plus 2 is reducing while the Pb4 plus is oxidizing. So now let us see the family number 14 with the its outer electronic configuration is ns2 and np2. Now in this one, due to inner pair effect, in the case of your this one compound, your tin, the plus 4 is the most stable state. Sn plus 4 is the most stable. Whereas in the case of the Pb, with the 2 electrons is the most stable oxidation state. In the Pb, these 2 electrons are not coming out for the reaction. The reason is call it as a inert pair effect. So, in the case of your lead, the highest oxidation state plus 4 is not possible. Tin, the lowest one is not possible. So, these two are only, what is it called? Possible oxidation state. So, Sn available plus 2 plus 4, the most stable is your plus 4. So, this plus 2, which is not stable, wants to come as a plus 4. That is, its oxidation number is increases. That means it is, that is Sn plus 2 is acting as a oxidation number increases. Mean what is happening to that? Its own oxidation number increases when it is acting as a reducing agent, because by acting as a reducing agent, it is itself increases its oxidation number. Whereas in the case of lead, plus 2 is stable, so plus 4 is not stable, which has to come down. The oxidation number should come down. So that means call it as a, it is acting as a oxidizing agent, so its number will be coming reduced. So this is the reason behind the your inert pair effect. So ultimately Sn plus 2 is wants to come as a plus 4. So your Sn plus 2 is acting as a reducing agent. Let us see the fourth option. Sn plus 2 is the reducing agent while Pb4 plus is the oxidizing agent. Now the reason is Sn plus 2 not stable, going to higher. So by reducing changes into plus 4. So this is the reducing agent. Plus 4 here in the case, this is not stable, it wants to come as a lower. So higher one to lower one means the higher is acting as a oxidizing agent. So this is the one of the trick. Or we can go to the other trick. Lower is acting as a reducing agent, higher is acting as a oxidizing agent. This is final and easiest trick is plus 2 coming as a plus 4, lower number reducing. Plus 4 to plus 2, higher number oxidizing. So your answer is Sn plus 2 is the reducing while Pb4 plus the oxidizing agent. So this is the short trick. Lower one acting as a reducing agent, higher one acting as a oxidizing agent. Let us go to the next question. What is the question is the stability of the plus 1 oxidation state among the aluminum, gallium, indium and thallium increases in the sequence. The options are available A, B, C, D. This is the year of 2015. Let us see the question again. The stability of plus one oxidation state. So this is the point we have to consider. Stability of plus one oxidation state among the aluminum gallium, that is the group number 13. Okay, before going to the option, let us see the influence of the inert pair effect in this group with the knowledge of what is it. Your member is here: boron, aluminium, gallium, indium, thallium, and this is NS2NP1 plus 1 oxidation state. So here in this case, what is the knowledge is your this one. These two electrons are not ready to coming out. Because of the not coming out, reason is inert pair effect. So what are the possible oxidation state for this one is, you can write plus 1 plus 3, plus 1 plus 3. Everything is extended plus 1 into plus 3. But in the case lower numbers are stable with the lower oxidation stable is stable. This one is available with the higher oxidation stable is stable. So based on the concept, the plus 1 oxidation state is plus 1 oxidation state stability is increases. This is the increases of plus 1 oxidation state because of the inert pair effect. Again I am telling, here in the case of boron, all the 3 electrons are coming out, plus 3 is most stable. In the case of thallium, since it is coming behind after the lanthanide contraction, that means what? These 2 electrons are not coming out because of the poor shielding of F electron which is going on in the lanthanide. These electrons are not coming out. That means what? NS2 electrons are not coming out. So this is available with the only one oxidation state plus 1. So your thallium is most stable with the plus 1. So the lower members are stable with the lower oxidation state. Higher members are stable with the higher oxidation state. This is the final tip. Higher members, the higher oxidation state. Lower members, the lower oxidation state. So coming to the point, the trend of increasing oxidation state across the group is your plus 1 is, let us write here, the thing is boron, aluminium, gallium, indium and thallium. This is the trend of increasing oxidation state. Now let us verify with the options. Who is matching with this? Aluminium, gallium, indium, thallium. The option is which is B is matching. So this is the answer trend. So only the trick is, what is the trick is? This is higher members or higher members mean I am talking about the at the position with the higher oxidation state, lower at the position there with the lower oxidation state. Thank you children.